Hi, and welcome to week 2 of Maya Bifrost training. This week we're going to be having a look at the new Maya Bifrost plugin, which comes with Maya 2015. And I'm just going to give you a rundown of what I think of the software and how to use it in an example Maya scene. So thanks for joining us, and let's get started. Now, one thing we might want to point out here is we know that Bifrost is good at jumping whales out of water and having the water splash back down. Looks pretty awesome. We've also seen it in use to render out separate passes. We've seen that it can handle huge particle simulations that take up 16 gigs of RAM. It can do ships. It can do turbulent ocean-sized water simulations. And it can also do smaller, detailed droplets of water, crashing geometry collisions, and glasses of milk. But I'm telling you right now, Michael Bay and J.J. Abrams are never going to ask you to put a glass of milk in the next shot. What they're going to ask you to do is smash a huge 2.5 kilometer wide Starship Enterprise through a futuristic San Francisco, or to crash a Ninja Turtle through a truck, or to shoot a bridge out with a helicopter that's while water's underneath it and there's debris and water splashing everywhere. So what I've set up is an actual realistic scene that is the kind of shots that we would work on in a summer blockbuster movie. So what I've noticed in Maya is the new version of 2015 is just super awesome. The new Viewport 2.0 controls really bring scenes to life, because you can actually put the lighting of the scene right into the viewport and render it with your graphics card. You can really start to art direct, and Maya becomes less of a sort of post-production modeling animation tool as it becomes a filmmaker's tool. Because if you can see the final look of the film in the actual viewport, where you can play blast and edit things interactively, kind of like PlayStation 4 graphics, it just becomes a really powerful tool, because you're not having to go and get a PhD from Stanford University in computer science before you can send your renders to a render farm of thousands of computers, and then the next week get your animation back. With this kind of setup where everything's graphics card rendered, you can actually just come up with ideas like I did with this helicopter chase sequence and go, I wonder if I could do, this, driving along this with the helicopter shooting it. As you're thinking, you're actually creating these ideas that you can actually put straight into your own films and then make them. It's just super awesome. If you're not an effects TD, you probably won't understand the significance of this new software to the future of basically animated and VFX feature films, because what it basically does is it's super fast. Anyone can use it without programming or expressions experience. It's installed on every version of Maya, so it's going to be getting massive widespread use. It doesn't cost anything extra. It's not like a $25,000 separate piece of software that's used just for fluid simulations. And lastly, it provides, it's hands down the best fluid simulation software I've ever seen or seen demoed or used. It's better than Naiad. It's better than all the in-house fluid simulation tools I've seen working at different studios. And yeah, it's just so easy to use, so fast, and enormously powerful in terms of the scale and complexity of water simulations that it can do. And basically what it means is that, civilian Maya users who don't have physics degrees are going to be able to put these awesome water simulations into their shots without any prior effects knowledge whatsoever. All you basically need to do is have the scale set of your scene correctly so that 1 meter is 1 meter. You don't need to put any settings into Bifrost Sims whatsoever to start with, and then you just basically cache the simulation with collision geometry and different settings like rigged into the geometry that you're crashing through the water, and it'll just come out looking like natural, awesome CGI water effects. So it's just going to be such a good tool, and it's going to really massively impact the VFX community, because now everyone is going to be able to do the highest end water simulations that are done on feature films straight out of Maya. So before we muck around anymore, let's just have a look at some example Bifrost scenes in Maya, and I'll show you how it all works. Okay, so if you just open up Maya, and if you don't have Bifrost already loaded, you can go into the plugin manager, and it's just in here. So you just click on load, and that'll load all the main Bifrost nodes and shaders and things like that into the system. So you can change the background color if you want to get a different clarity to the particles you're looking at. Now we're going to go into load Bifrost example, which is in the Bifrost menu at the top, and then we're going to go onto this wave paddle shoreline, which is a really fast simulation to run, which will work good for this tutorial. So with water simulations, they usually follow a 3-step process. You create collision geometry using polygons, which you can animate. You then simulate particles flowing over the collision geometry, or being filled in the collision geometry, and then you mesh the particles. And it's best to do this at render time to avoid massive time and disk usage. So RealFlow actually meshes in the actual software, so you've got to bring in and bake out. So we're just showing the voxels there, so you can switch between particles and voxels. So in RealFlow, you bake out Maya scenes and then bring it into RealFlow, and then calculate the particles and then mesh the particles and then render them. So it's like 1, 2, 3 renders basically. But in Bifrost, it's straight in Maya, so you can edit and set up everything all in one hit, which is awesome. So this is a look at the meshing. So when you click meshing, this will actually put the triangulated geometry around the water particles. So if we have a look here, that's the actual final rendered surface that we'll make. So this one's set super low for the sake of interactivity, but in your final shots, the unbroken water that's not the kind of powder spray like foamy particles that are coming out, the main surface that's all sort of cohesive, that's actually this mesh geometry that we see in there, whereas the spray is kind of more the particle systems to keep the detail towards the edges. And basically how it works is Mental Ray or Redman or Arnold or whatever renderer the show that you're working on is using, it will actually mesh this at render time, and it will render different passes so that you can get the spray areas of the particles, like where that white area is, to show up as a kind of foamy surface, whereas the main body of the water, which is meshed, will show up as a transparent, refractive, oceany kind of water. So what we can do is enable background processing and scratch caching, which will give us our background Bifrost processing. So how this basically works is the Bifrost is a separate program to Maya that runs invisibly in the background. So what happens is when you press play in the time slider, it actually requests that these frames are sent to Bifrost in the background. So where you can see the green bar on the left of the time slider, that's Bifrost background processing the the simulation on extra threads of the CPU while it leaves the main threads available for Maya to keep working. So I've just paused the video and waited till this has gone to 160 frames. And what's really good is while it's background processing, you can still interact in Maya. So you don't need to, it doesn't freeze the session that you're working in. You can still keep working and setting up the scene. So as you can see, I can actually scrub through this timeline where the green is really fast because it's actually loading out of RAM. So for my RealFlow computer that I used to operate, I actually had a fiber channel disk array that I had to play back the disk saved particles on so that they're able to play back. But Bifrost is smart enough to load things into RAM so that you can interactively play them back. Then when you're finished, you cache it to disk. So what we're going to do now is this little sphere here is actually a collision object that you can interact with the Bifrost fluid. So what we're going to do is, we can see here it's solid collider mode as opposed to shell. And if we have a look at this wave collision object, in the settings for that, it's actually set to solid as well in the Bifrost collision mode. And what that does is it means that no particles will penetrate the inside of that object. But with the container that's set to be the beach, we can see that this collider mode is actually shell. So the water can fill the inside of it without the particles being repelled out of it. So this geometry here that we can see, that's actually the water emission geometry. So that object there is filled even though it's not a collider. So that's the initial state, if you like, for the water to appear in the scene, and then it can get flowed along the kind of tray, paint tray that's in the bottom. So this is a pretty good setup. I mean, it's easy to use, it's good to learn with, and you can also see later that we'll be able to increase it. So what we're going to do is we're going to get this collision ball and add a few keyframes into the scene, and we're just going to disable Bifrost so that we can quickly animate this without having to worry about updating particle sims and things like that. So I'm just going to move it up. I'm going to animate it going down through the water and then back up again. So what we're going to do is just key the translate, move the keyframes along a bit to about frame 50, and translate it down, key those. So you just right click to set keys, and then we're going to move it up again and key it. So now we've got two keyframes going down, going up. So one thing just to note is this is moving pretty slowly, but it's not to say you can't move things the speed of bullets, but if they intersect with the water over several frames, it gives you better fluid results if you're only calculating it per frame. So if I was to fire a bullet through this water at the speed of a bullet, it may not intersect with the water on any frames. It may just go straight through because it's been translated so fast. So just be aware of that to move your objects at a sensible pace through the water, or set up your scenes to be simulated slow motion and then speed them up in post. So we've got this collision object, goes down through the water, back up again, and what we're going to do is we're going to send those frames through to be cached, and this is the result that you get. So when we select the Bifrost fluid, what you can see is that these have been background rendered while the video was paused, and I just allowed them to the simulation to run in the background until it was completed, which took a couple of minutes, and then this is the output that came out. So it splashes up really nicely when it goes in, and then it sucks onto the shape as it's pulled up out of the water, kind of like a scuba diver surfacing out of the water. So it's really awesome. It's just so natural and lifelike. The solver for this Bifrost water is obviously very sophisticated. It's got lovely tendrily bits of particles on there. It's nothing like the Navier-Stokes solver or the N-particle solver. It's extremely fast to simulate, and the detail that's in the splashes and the tendrils of water is really impressive, especially on these extremely low detail settings for this demo water scene. I mean, you can increase the detail 10 times for this water, although it simulates slower. But to get this amount of performance out of that low voxel count, which you can see here, it just looks blobby, is really impressive. So the other thing to note is this is a very sophisticated particle simulation from an FXTD point of view, and we haven't written one line of expressions or code into the particle itself. So if you're going to do this with Maya particles, you could probably fake something similar, but it would take a huge amount of expressions and code to get the particles to string together like that and to self-collide with each other. And it would be very, very slow to run. So overall, it's just a really good simulation software for water. So when you mesh this, you can see that this is fairly coarse mesh because of the low detail of the water simulation, but this is totally sufficient for TV series or TV commercial work that has fast turnaround. And because you're not having to write tons and tons of code or save these geometry files to disk on every frame, you'll just be able to run these simulations to quickly get a desired result for a Pepsi commercial or something like that. And then you'll just be able to quickly render it on the farm and then give it to a Flame or Inferno compositor that same day once you've finished. And they'll get a much nicer effect than that will be custom made to the shot that they want to achieve. You know, this is great for Lipton iced tea type TV commercials that use a lot of real flow and CGI effects. It's great for Wide World of Sports, kind of tennis, football, and all those kinds of sport stings, opener and closers type effects, where they do a lot of fluid and particle simulations as part of the openers and closers. So obviously, where you want to take this from here is if you're doing a more detailed shot for a film or for a high-end TVC, you'd be wanting to increase the particle count. So even though we've got a lot of particles in this shot, you can see that the geometry that's output isn't the same fidelity as a kind of ocean. It's looks like more like a glass of water. So the way that you get that huge scale is by increasing dramatically the particle count and the scale of the scene, so that there's billions and billions of particles that the geometry is able to tightly mesh around. So the fewer particles you have, the more blobbier and the more low detail your mesh is going to look when you finally render it. So don't get too hung up in trying to do tricky meshes that look super detailed, because that's not really the objective. The objective is the particle simulation. It's all the rendered look of the water will be driven off the particle sim, not the by tricking the mesh to try and make it look more detailed than it is. If you put the detail into the particles, that'll really make the water look the best. So let's have a look at this. I just made another second sphere here, and I'm going to animate it splashing into the water. So one of the drawbacks of other fluid sim software is that you have to animate a scene and then export it, baking every frame, and then import it into your scene, say like RealFlow or another software. Then you have to simulate it, and then you have to mesh the simulation, and then you have to re-import the mesh into Maya, and then you have to apply shaders and render it. So the great thing about this is often you're doing really simple collisions like spheres or tennis balls or logos and things like that. And other times they're more complicated. But we all know that animation gets iteratively updated all the time. So it's a massive, huge nuisance to have to bake the keys of animation every single time there's a revision onto the shots, and then re-simulate the water over several days. I mean, the ability to be able to get these little simulations and just move the geometry around and change it is just so good. So I've just paused the animation and cached this thing so we can see. So we can see now we've got a new simulation with two collision objects. One is the ball sphere that's come through, and the other one is the original collision object. So you can see that you don't wreck the simulation or its settings by adjusting the scene. You can easily adjust it as much as you like. So we're going to just reset this scene. I'm going to import a helicopter into it to show you a more complicated shot. So I've got this helicopter. It's off a free Maya model off the internet. It's a very basic kind of game resolution helicopter, which is perfect for water simulations because you don't want the geometry being too complex. So just going to turn my anti-aliasing on so it looks a bit nicer. And what I'm going to do is just to show you how this works is we've got the default Bifrost flowing waves scene, and what we're going to do is we're going to scale up the container and the emitter box. So what I'm showing you here is if you wanted to increase the scale of a low resolution fluid sim, you can just do that by scaling the fluid container and the fluid emitter to be larger. Now, this isn't probably the most technically accurate way to do this, but what it's showing you is that you can quickly increase the size of fluid sim setups without having to completely make everything again from scratch. So this is the wave generator. So I'm just going to adjust the sine handle on that to cover the whole length of this and increase the amplitude. And this is exactly the way that I did the James Bond chase sequence. I just was really impressed by this beach simulation, the way the waves like went up the shoreline and how fast it was to simulate with such awesome detail. So I just made a really long, several hundred meters long version of this beach, and then that's what I used to do the helicopter chase sequence. So we're going to do that in a later lesson, but at the moment we're just going to work on doing a shot where this helicopter crashes into this ocean sort of surface. So what we're going to do is set the keys on this chopper, go to frame 40, move the helicopter forwards and down, so it's definitely in the fluid surface. I'm not going to worry too much about running a rigid simulation or anything at the moment because we're wanting to hand control this animation, and then I'm just going to rotate it over and upside down so that it's sort of tipped over and it's sort of wrecked. So we don't want it to kind of keep flying underwater. We just want it to just sort of die when it hits the ground. So we can see that this animation is a little bit too quick. So if we go back to frame 1 again and press play, what we're going to do is just move those keyframes a little bit further forward so that it hovers in a bit slower, a bit more realistic. And then we're going to just check that out and see how that looks. So that's a little bit too slow. So we're just going to adjust a few of its tangent settings. So that's sharp tangents instead of flat tangents. So now it's coming in. Oh no! Helo going down. So that's got a much more kind of realistic speed to it. And that's going to work well with the water, because one trick with scale is if you want something to look really big, you've got to move it really slow so that it's sort of not moving around like it's like a little radio controlled aircraft or something. You need to have big vehicles and big water react in a slow motion kind of way so that it looks like the right scale. So this should work pretty good. The other thing is we don't have rotating blades, so we're just gonna, rather than keyframe this, we're just gonna put a quick expression onto the blades so that they can spin without having to animate them. So I'm just gonna say blades rotate y equals time. So the frames of the animation will actually increase the spinning times 600. So usually 600 to 1200 is a good amount for rotating helicopter blades. So we'll just see how this works and play it back. So that's probably realistic for like takeoff kind of thing, but this one's kind of going to be at full power because it's about to crash. So we just might increase that a little bit, and we just usually have to increase it, see how it looks, and then make adjustments as necessary. So that looks good, but it might be a little bit too fast for the water simulation. It's probably realistic, but for the water to interact with the blades, then just need to be fast, but not ridiculously fast. So we're just going to stick with this one, and that should give us a pretty good result, churning up that water into a kind of foamy mess of helicopter death carnage. So I mean, without water in the scene, it looks pretty boring. So to comp in real water would be pretty tough. So I'm just going to pause the video, and what we're going to do is we're going to I'm going to background sim this water and load it into RAM, and then once it's finished, we'll unpause this video, and then we'll be able to check out how the final animation looks. So don't get worried if your Bifrost container is the wrong size. That's just because it hasn't loaded the particles from the latest simulation. So what you'd be wanting to do is make sure you select the Bifrost container and your helicopter, go up to add collider, and once that's done, you'll be able to get the helicopter and the Bifrost liquid to collide with each other. Just make sure that you select the geometry instead of the parent node, because that's just not geometry, it's just a null object. So you need to select the actual polygons themselves to collide objects together. So now we're just going to enable our Bifrost fluid. Scratch cached is enabled, and then we're just going to press play, submit those 112 frames to be rendered by Bifrost, to be simulated by Bifrost, and then we're just going to wait till that fluid is finished, and then we'll be able to check out how it looks. So one thing to note is this is going to be a lot larger scale. So we've just paused the video, and that's the final sim. So with these larger particle sim, sometimes the RAM may not be able to play back in real time the simulation, and that's just because each frame of this helicopter crash could be up to 200 or 300 or 600 megabytes per frame. That's how much memory the particles actually take up to simulate. So that's why it's a good idea. You know, this is computer's got 16 gig of RAM on it, so you can see that even with that fast RAM, it's pretty sluggish to pull through, and that's totally normal. Don't think that there's anything wrong with your computer because you're not able to pull through multi-thousand megabyte simulations. So what we're going to do is actually, that just looks awesome, that simulation. So we're going to go to frame 1, play blast, and then check it out. And that's a totally normal Maya workflow when you're working with heavy scenes. So we can see that there's a massive amount of fluid detail in that scene, and it just looks really, really nice. And the speed that it can to simulate only takes like a couple of minutes to simulate that massive helicopter crash. And the scale of it, once you've added in the lighting and the comping effects, and you've put in smoke and other elements like that, that particle sim is just going to look amazing in your shots to get once it's got motion blur and all the effects on it. And don't worry about the meshing too much, because all the different passes that you output can be blended together so that you're not just working with one sort of all-encompassing pass that does everything. You can render out the mesh, and if it doesn't look super detailed, you can always comp the particles motion blurred over the top with just the velocity on them so that you can get the spray really detailed. So the spray you wouldn't probably mesh, you'd just have that as particles to get the super detail look. But as you can see there, the blades are smashing into the water, the foam's getting kicked up everywhere, the particles are connecting to each other, so you can see really natural cohesive shapes forming in the fluid simulation as it's crashing into the water. So the particles will kind of gather together into force, like showing the force of the impact, and you'll be able to see that the spray is really thin and really delicately contoured out from the force of impact, but yet the voxels is really low. So you can see here the voxels are really blobby, whereas the particles are super detailed. So we'll just turn on the mesh here just to show you. So because this is much more detailed, higher particle count, the meshing takes a few more seconds to calculate, but the meshing is basically used to render the main flat surface of the water, not the spray. So don't get frustrated if you mesh your whole thing and you're like, damn, I didn't get the detail I wanted. But the meshing is really meant for the main body of water, not for the not for those tiny little droplets all over the place. This is doing a great job of rendering and connecting together a surface of water that you can use to comp the spray over the top of. So yeah, we can just really see that this has just got amazing. The other thing to notice too is Viewpoint 2.0. There's been extra additional things written for it to load and display that many particles. In previous versions of Maya, you weren't able to load billions of particles into the scene and visualize them this fast on fairly inexpensive graphics cards. But anyone with a $70 GPU will be able to load this much this much particles into their Maya session and look at the results now with Viewpoint 2.0's massive enhancements. So one of the most powerful features of Bifrost is the ability to interactively update your animations without having to sort of program swap. So we haven't written any expressions to use Bifrost. We haven't written any code. We haven't had to import or export into any other software. We haven't had to connect nodes together and do all these complicated settings for internal and external pressure. All we've basically done is just scaled up a smallish sim and put some animated geometry into it. So what I've done now is I've just updated my helicopter, the animation. So the helicopter will come in and then pull back as it's about to crash, as if the pilot is pulling back on his stick to try and avoid the impact. And then what happens is the water will now simulate totally differently because the helicopter is kind of falling into the water, rotors first or body first instead of nose first. So what you can do is once you've changed your animation, you can just save the Maya scene as like, version 2 helicopter crash, and you can look at both of them in dailies and say, hey, you know what? We really like version 1. Why don't you stick with that, and then we'll change it. Change it in this way, and that way you're not having to constantly like have massive disk usage for particle sims and setups. Plus, it simplifies the whole baking process because all the curves on my helicopter are still intact. I haven't had to bake every frame of its animation and like wreck the animation curves. I've just been able to tweak the rotation curve so that he now goes in tail first. And now my simulation looks totally different. Instead of spraying forwards, it kind of sprays upwards, and the impact is more localized to where the helicopter falls in. It's kind of like got a violent upwards explosion look on it. So depending on the collision animation that you have with the water, you'll get a totally different result each time. And I guess the power is of the power of this software that's just going to smash the competition is that there's just no need to have to constantly export and import meshes and export. It's just so much of a faster process, and it's so user accessibility is like 11 out of 10 because you don't need any effects training basically to get it to work and produce amazing results. So don't one of the main things is just to be conscious about the way that you're simulating it. Like, you don't need to make physically realistic depths to the water. That's a bit of a noob mistake that I've seen a lot of simulating people use, is they make 70 meter deep water because that's how deep the ocean is. Don't do that. Just use water that's thin enough to render correctly, but don't use like a physically accurate depth to crash things into, unless you're actually going to crash a hole into the water that's 70 meters deep, if that makes sense. So if you're going to be crashing this helicopter in, if this ocean is 2 kilometers deep, there's no need for this water to be any deeper than, say, the 20 foot that this helicopter goes into it. There's no it's totally unnecessary to make it like 1,000 meters deep in a huge cube. So just have the the water detail where it's needed, like right in front of the camera, and it's really the surface of the water that you're trying to dissipate and render and blow apart, not the deep undercurrents of the water. So that's one of the main tips that I can give you for working with this kind of water software. So we can see this is going right in there. Bam! Just looks awesome. So if you want to combine that with rigid simulations where you smash the helicopter apart and you split those blades off, that'll look even better. But already you can see how such a boring animation that looked really amateurish is starting to look super like exciting and dynamic, because you've got this you're crashing this helicopter into a totally like dynamic substance, which is really going to react violently to any kind of animation that you put in there. So I haven't hand animated all these particles or put in settings or anything. This just automatically happens as a result of flying the helicopter into the water. So this has just got profound impacts for profound sort of changes is going to happen to TV commercials, short films, the entire visual effects kind of industry, from having large-scale water just be a natural part of every shot that you need to put water into. I mean, if you're able to do this in a few seconds in Maya, imagine what you can do in like a few weeks or a few months for feature film characters and stuff like that. I mean, you're going to be able to make creatures out of water that run around. You're going to be able to easily like crash thousands of helicopters or jets into water. You're going to be able to have whole feature films set in water, interacting with water. And, you know, it's going to be still random challenges and things like that. But in 3D stereoscopic filmmaking, this is just a godsend because it's so fast and easy to use. And people are just going to be able to just get going with it straight away, basically, without having to have 50,000 effects TDs working on all the shots. So one thing we're going to do here is at frame 1, this fluid is totally, totally flat because it's only being emitted at frame 1. And we really want to get some pre-roll so that we can get the sort of waves happening on it, so that as the chopper's coming in, we get some kind of action happening. So you can do this with all the different Bifrost sims. You know, you can do a pre-roll to set up the water to have a sort of initial state that loads it ready for the first frame of the animation. So what we're going to do here is we don't have any pre-roll frames on this helicopter shot, so I'm just going to set it to -50 for the start frame. And then what will happen is the waves are kind of going to start flowing along at -50, and then that will actually start moving the water, so that by the time we get to frame 1, there's going to be a little bit of animation on the water, so that we're not just going to be flying this chopper into like a totally flat sort of lake type water. We're going to be more sort of rippling ocean water. So this beach geometry is quite steep, so we're not probably going to see all these different waves that are coming up the beach. But the main thing is just to get a bit of movement in there, so it's not totally static at the first frame. So we're just going to load in the turn off particles so that we can get a bit faster playback. Just submit these frames, and just be aware that the more pre-roll that you have, the more time it takes to simulate, because you're having to submit so many extra frames that effectively just get thrown away. So I wouldn't recommend, you know, having a pre-roll of like 350 frames so that you can load it in, because it's just a waste of processing time. So you can see here, like 1/4 of our processing is just going to get chucked out. So I've cached this from -50 up to 135. So I'm going to set my start frame back to 1, and then we're just going to have a look at how this guy crashes into the water. Just zoom out so we can see the details. And what you're going to see is that the now we've got that nice undulating kind of water surface, which will render really nicely with some reflective water shaders on it. So when we crash this chopper into the water, we're going to see that it creates like a really awesome effect. And because there's a bit of pre-roll, the water's sort of already in movement, so it'll kind of have a bit more natural effect. Bam! I can just see that so many people are going to have so much fun with this software. I think YouTube is going to be filled with thousands of Bifrost simulations. And anything that you can imagine, any expensive, elaborate water stunt sequence you can imagine, you can basically create, and it will happen exactly as it would in real life. So, you know, if you can imagine a jet fighter crashing into water, X-Wings smashing into water, you know, battleships sailing through the sea, helicopters crashing, car chases, characters, giant robots fighting in water, anything that you can kind of think of and imagine, you can basically quickly recreate. and just see how it looks. Even if you don't even use it, you can just go, I wonder what that sequence looks like. And then you can just put it together, have a look at it and go, wow, that looks awesome. And if it doesn't look awesome, you can just try another idea and you haven't lost heaps of time. So, this is going to be just a great, one of the most powerful tools for this, will just be for prevising expensive water sequences. And it's just going to be so awesome. So the last stage you need to do is once you're happy with your simulation, you go up to Bifrost cache to disk, which doesn't cache it temporarily to RAM. It actually permanently writes out particle frames. And then you go time slider, and then you hit create. So that's concluded our Bifrost week 2 training. We just didn't want to confuse you too much with technicalities at the moment, but we just wanted to give you a quick introduction to this very sophisticated and awesome water simulation software. So there's a lot more to cover in the following weeks, but yeah, hopefully that just gets you a rough and ready look into the software.